Hi everyone. So this is part 2 or the continuation on our topic on ellipse. So to start, we have here how to write the equation of the ellipse in standard form given the vertices and foci of an ellipse centered at the origin. We have here certain steps, 3 steps that we can follow. So the very first one is determine whether the major axis lies on the x or the y axis. So that's the very first thing that we need to do or to determine. So we know from the previous discussion that if the major axis lies on the x-axis, that's an indication that your ellipse is horizontal in nature. And if the major axis is on the y-axis, that means that the orientation of the ellipse is vertical. So 1.1, if the given coordinates of the vertices and foci have the form positive negative a0 and positive negative c0 respectively, then the major axis is the x-axis. So use the standard form x squared over a squared plus y squared over b squared is equal to 1. So if you're given the vertices meaning the endpoints of the major axis as positive negative a squared 0, and if you are given the foci positive negative c 0, that's an indication that the graph or your ellipse is horizontal. Why? Because we have coordinates of the x-axis, meaning the points are located on the x-axis. Okay? So by that, we will be using the standard equation or the standard formula x squared over a squared plus y squared over b squared is equal to 1. Okay? Next, if the given coordinates of the vertices and foci have the form 0, positive negative a, and our foci is positive negative c0 respectively, then the major axis is the y-axis. I'm sorry, this one right here, that should be 0, positive negative c, since for that the orientation is vertical. So anyway, if we know that the vertices and the foci are located on the y-axis, since we have here coordinates of the y-axis, meaning our ellipse, the orientation is vertical. Therefore, we will be using this standard form x squared over b squared plus y squared over a squared is equal to 1. So use the equation c squared is equal to a squared minus b squared along with the given coordinates and the vertices and foci to solve for b squared. Actually, given this equation, you can actually solve for c, a, or b. Then third step is substitute the values of a squared and b squared into the standard form of the equation determined in step 1. So to understand that further, let's have an example. Example number 1, writing the equation of an ellipse centered at the origin in standard form. The question is, what is the standard form equation of the ellipse that has vertices positive negative 8, 0 and foci positive negative 5, 0? So just taking a look at those given points, we can already determine or identify as to what the orientation of our ellipse will be. So for the solution, The foci are on the x-axis, so the major axis is the x-axis. So since the given points for the vertices, the coordinates are coordinates of points on the x-axis, we know that our major axis is the x-axis. So thus, the equation will have the form x squared over a squared plus y squared over b squared is equal to 1. That will be the equation that we will be using for this certain example. So the vertices are positive, negative 8, 0. So a is equal to 8 and a squared is equal to 64. So we know that is given. So to the right side it's positive, to the left side that's negative. But irregardless, so we know that a is 8, and if we square that one, that will result to 64. Now the foci are positive, negative 5, 0. So we know that c is 5, and if we square that one, c squared, 5 times 5, that is 25. So we already have values for our a and for our c. So using the formula c squared is equal to a squared minus b squared, we can solve for the value of b. How can we do that? We just need to substitute the values of a and c to the given equation. So we know that c squared is 25, and we know that a squared is 64. So substituting, that's 25 is equal to 64 minus b squared. Then solving for b, here we just move that one to the other side of the equation. So since that's negative, it became positive b squared. And then subtracting 64, then moving 25 to the other side of the equation. So that's 64 minus 25. That gives us the answer of 39. So now we only need to substitute a squared, which we know is 64, b squared, which we know is 39, to our equation. And since this is a horizontal ellipse, or the major axis is on the x-axis, a will be put under x, b will be under y. So therefore, the standard equation is this one: x squared over 64 plus y squared over 39 is equal to 1. Now we have here a question, Q&A. Can we write the equation of an ellipse centered at the origin given coordinates of just one focus and one vertex? So the answer is yes. So since ellipses are symmetrical, meaning whatever is on the right side is the same on the left side, so the coordinates of the vertices of an ellipse centered around the origin will always have the form positive, negative a, 0, or 0, positive, negative a. So similarly, the coordinates of the foci will have the form positive, negative c, 0, or 0, positive, negative c. So knowing this, we can use a and c from the given points along with the equation c squared is equal to a squared minus b squared to find b squared. So the whole idea is, if you will be given only like a half of the ellipse, will you be able to determine the other half? Of course, since again ellipses are symmetrical in nature. Now this time, we will be writing equations of ellipses not centered at the origin. So earlier, the center, the C was at the origin 0, 0. This time, what if the center is not anymore at the origin? So like the graphs of other equations, the graphs of ellipse can be translated, meaning it can be placed on other parts or quadrants of our Cartesian plane. if an ellipse is translated h units horizontally, so if it will be moved h, like let's say horizontally, h units and k units vertically, the center of the ellipse will be hk. So instead of 0, 0, the center will now be hk. So this translation results in the standard form of the equation we saw previously, with x replaced by x minus h and y replaced by y minus k. So if you can still recall, same with the circle, there are circles at the origin and circles not at the origin. Also with the parabola. So general note, standard forms of equation of an ellipse with center hk. So meaning, if we say hk, the center is not anymore at the origin. So the standard form of the equation of an ellipse with center hk and major axis parallel to the x-axis. Parallel meaning it's parallel to, it has, if the major axis is horizontal, that's parallel to the x-axis. If the major axis is vertical, it's vertical to, it's parallel, I mean, to the y-axis. But this time, let's have first the ellipse wherein its major axis is parallel to the x-axis. So this will be the equation or the standard form. X minus h squared over a squared plus the quantity of y minus k squared over b squared is equal to 1. Where, same with earlier, or I mean with the previous discussion, a is greater than b. The length of the major axis is still 2a, since it's a units to the right, a units to the left. Then the coordinates of the vertices are h plus minus a k. So this time, since it's not anymore at the origin, we will be using the coordinates hk. The length of the minor axis is 2b. The coordinates of the co-vertices are h k plus minus b. The coordinates of the foci are h plus minus c k, where c squared is equal to a squared minus b squared. So anyway, that will be elaborated later on. Next, we have the standard form of the equation of an ellipse with center hk and the major axis is parallel to the y-axis. So this time, this is a vertical form of ellipse. So the general formula or the standard equation, I mean, is the quantity of x minus h squared over b squared plus the quantity of y minus k squared over a squared is equal to 1. Where, of course, a is greater than b, since the major axis is always greater than the minor axis. The length of the major axis is 2a. The coordinates of the vertices are h k plus minus a. So that's it. The length of the minor axis is 2b. The coordinates of the co-vertices are h plus minus b k. And the coordinates of the foci are h k plus minus c, where c squared is equal to a squared minus b squared. So just as with ellipses centered at the origin, ellipses that are centered at point hk have, of course, the same parts. Still have the same vertices, co-vertices, and the foci that are related to the equation. C squared is equal to a squared minus b squared. So we can use this relationship along with the midpoint and distance formulas, which you are already familiar with, to find the equation of the ellipse in standard form when the vertices and foci are given. So these are illustrations of ellipse not on the origin. So this one right here, the center HK is at a point in the x-axis, and this one right here, the center is can be located inside the quadrant 1. Okay, so again, these are ellipses wherein the center is not anymore at the origin but at a certain point HK. So H units horizontally or vertically, and K units horizontally or vertically, whatever the orientation of the ellipse might be. So how to write the equation of an ellipse in standard form given the vertices and foci of an ellipse not centered at the origin. So earlier in this video, the first part was how to write the standard form when the ellipse is at the origin. But this time, what do we do if the ellipse is not anymore at the origin? So we have 6 steps right here. Number 1, first thing we need to do is determine whether the major axis is parallel to the x or the y-axis. So even if your ellipse is at the origin or not, that's the very first thing that you need to do or determine. So you have to identify if the ellipse is parallel to the x or the y-axis. So number 1.1, if the y-coordinates of the given vertices and foci are the same, then the major axis is parallel to the x-axis. Take note, if the y-coordinates of the given vertices and foci are the same, then the major axis is parallel to the x-axis. So you will be using this standard equation: x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Next, 1.2, if the x-coordinates of the given vertices and foci are the same, so then the major axis is parallel to the y-axis, and you will be using this standard equation. Okay? Step number 2, identify the center of the ellipse HK using the midpoint formula and the given coordinates for the vertices. So later on, you will be refreshed or reviewed on the concept of the midpoint formula. Step number 3, find a squared by solving for the length of the major axis, 2a, which is the distance between the two vertices. Step number 3, find c squared using h and k, found in step 2 along with the given coordinates for the foci. Step number 5, solve for b squared using the equation c squared is equal to a squared minus b squared. And step number 6, substitute the values for h, k, a squared, and b squared into the standard form of the equation determined in step 1. Now let's have an example. Example number 2, writing the equation of an ellipse centered at a point other than the origin, meaning the center of this ellipse is not at the origin. So the question is, what is the standard form equation of the ellipse that has vertices -2, -8, and -2, 2? So since these are the vertices, meaning these are the endpoints of the major axis, and the foci -2, -7, and -2, 1. So these are the two fixed points or the foci. So observe that all the x coordinates are the same, which are all -2. So let's proceed with our solution right here. The x-coordinates of the vertices and foci are the same, so the major axis is parallel to the y-axis. Take note of that. That was given on the steps earlier. So since all the x-coordinates are the same, the major axis is parallel to our y-axis. Thus, the equation of the ellipse that we will be using will be of this form: quantity of x minus h squared over b squared plus the quantity of y minus k squared over a squared is equal to 1. So first, we identify the center, hk. So the center is halfway between the vertices -2, -8 and -2, 2. So take note, there were 4 given points. 2 points were that of the vertices, 2 points were that of the foci. So if we are given the vertices or the endpoints of the major axis, we will be able to solve for the center by using the midpoint formula. So if you can still remember, the formula for the midpoint was m quantity of x sub 1 plus x sub 2 over 2, then comma, y sub 1 plus y sub 2 over 2, since we are looking for coordinates of the center. So we have here the solution in order to solve for the center, hk. So that's we can have this one as our x sub 1, y sub 1, x sub 2, y sub 2. So substituting, we have there -2 plus -2 over 2, comma, since again these are coordinates, then -8 plus 2 over 2. So solving, -2 plus -2. That's actually, I'm sorry, that's actually wrong. It should be -4. Yeah, that's correct. I'm sorry. -4 over 2 is equal to -2. Then -8 plus 2, that's -6 over 2. That gives us -3. Okay? So, -2, 3, that is the coordinate of our center. So, our h is -2, our k is -3. So, after solving for the center, we proceed to solve for a squared. So, the length of the major axis 2a is bounded by the vertices. We solve for a by finding the distance between the y coordinates of the vertices. So, if we will try to illustrate that one, if this, I'm sorry. So, if this is our y-axis, -8, if this is the center, or if that's the origin there, -8 is somewhere below here, and 2 is up here. So, in order to determine the length here of the major axis, we need to solve for the distance between the two. So we know that the coordinates are again -8 and 2 there. So by subtraction, that's 2 minus -8, that gives us 10. But since we know that the distance of the major axis, the whole axis, is 2a, solving for a, simply a, we divide both sides of the equation by 2. So that gives us 5. So if a is 5, therefore a squared is 25. So we already know our center, we already know the value of a. Now we find c squared. So the foci are given by h, k plus minus c. So h, k minus c is equal to -2, -7, which was given earlier. And h, k plus c is equal to -2, 1. So again, these were given earlier. We know that those are the coordinates of our foci. So this one right here is on the left side of the Cartesian plane, since the y coordinate is negative. and this is on the right side of the Cartesian plane since the y-coordinate is positive. So we substitute k is equal to negative 3 using either of these points to solve for c. So you can use either this one or this one. By the way, if you are wondering where we got this k, so earlier we were able to solve for the value or the coordinates of the center, and we know that the center is represented by hk. So we know that h is negative 2 and k is negative 3. And for us to solve for c, we are using the values of our foci since that is already given. So here we use the positive coordinate for the foci, so that's k plus c is equal to 1. So this one right here. So since we know that k is negative 3, so solving for c, moving negative 3 to the other side of the equation, so that will become positive 3, and 1 plus 3 will give us the answer of 4. And since c is equal to 4, if we square that one, therefore c squared is equal to 16. So we already know the value of our center. We already know a squared, c, and c squared. What's remaining is for us to solve for the value of b squared. And since that's the only value missing, we can use the formula which we have used earlier. C squared is equal to a squared minus b squared. Substituting, so c squared, as we all know, is 16. A squared, as we all know, is 25. Then solving for b, moving b to the other side, that's negative. That will become positive b squared. Then moving 16 to the other side of the equation, so that's 25 minus 16. That is why we have b squared is equal to 9. Then since we have already solved for all of the values, we know that hk, we already have the values of hk, we already have a, and we already have b. So going back to the standard formula or the standard equation, so that's x plus 2 squared. So if you will be wondering why 2 is positive, we know that the formula was x minus h. So if that's negative of negative 2, that will become positive 2. Also, consequently, since our k is negative 3 and the formula or the equation is y minus k, so y minus negative 3, so negative and negative, that became positive. And we already know the value of b, which is 9, and the value of a, which is 25. Therefore, this is the standard equation of the ellipse given the endpoints of the major axis and the coordinates of our foci.